In this tutorial, we'll talk about significant figures, also known as sig figs. We'll describe what they are, how to identify them, and rules for keeping track of them. Let's begin with what they are. Anytime you take a measurement, there is always some experimental uncertainty in that measurement. And significant figures are a simplified way of reporting what that experimental uncertainty is. Let's look at a few examples. Suppose I measure the mass of an object and I report it as 2.107 kilograms. What I'm really saying there is that when I measured this, I know that the actual value is somewhere between 2.1065 kilograms and 2.1075 kilograms. It's somewhere within this range, but I don't know exactly where within this range, so I report it in this fashion. Likewise, suppose I measure the length of a particular object and I report it as 0.03 meters. When I report it in this fashion, what I'm really saying is that the length of this object is somewhere between 0.025 meters and 0.035 meters. I don't know exactly where within this range it is, so I report it as 0.03 meters. Let's look at another example. Suppose I measure the time for something and record it as 1.4 seconds. If I report it in this fashion, what I'm claiming is that the actual time is really somewhere between 1.35 seconds and 1.45 seconds to reflect the uncertainty in the measurement. On the other hand, if I measure the time and I report it as 1.40 seconds, then what I'm really claiming is that this time is actually between 1.395 seconds and 1.405 seconds. So if you look at this example and compare it to this one, you see the importance of significant figures. Significant figures are a shorthand way of telling your reader what the experimental uncertainty in your measurement is. Next, we'll describe some rules for identifying the number of significant figures in a measurement. Suppose I measure the mass of an object and I report it as 23.678 kilograms. In this case, there are a total of 5 significant figures. Each one of these digits here is significant. So there are 5 significant figures in this example. And as a general rule, anytime you have a number and there are non-zero digits are always considered significant. So in this example, we counted up 5 digits. They were all non-zero, so there were a total of 5 significant figures here. In this next example, there are 7 significant figures. And as a general rule, anytime there are zeros that appear, but they appear sandwiched between non-zero numbers, then those zeros count. In other words, they are significant. Similarly, in this example, 10.3, there are 2 non-zero digits and a 0, but that 0 is sandwiched between 2 non-zero numbers, so we count up all the digits and we get 3. So there are 3 significant figures in this case. On the other hand, sometimes you'll write a number like this, 0.003, or this one, 0.000015, And there's a whole bunch of zeros on the leading edge here. These zeros are not sandwiched in between two non-zero digits, and they are in front or on the left of the first leading digit, non-zero digit. So therefore, these zeros do not count. So if I was totaling up the total number of significant figures in this number, these three zeros don't count. That 3 counts as a significant figure, so this thing has a total of 1 significant figure. If I look at this one, these zeros on the leading edge here don't count, and we have 1, 2 significant figures in that example. So as a general rule here, zeros to the left of the first non-zero digit are not considered to be significant figures. However, if there are zeros that appear on the trailing edge, in other words, on the right after the decimal point, then these are considered to be significant figures. So these two zeros would be considered significant. Likewise, this zero here, since it appears on the right following the decimal point, it is considered to be significant. So in these two examples, this first one here has a total of 4 significant figures, while the next example has 3 significant figures. And as a general rule, zeros to the right of the decimal place are always considered to be significant. In this next example here, notice that there are a total of 2 significant figures. And I put this example here to illustrate the contrast between writing something as 1.7 seconds or 1.70 seconds or 1.700 seconds. These three numbers are not the same because they're conveying different amounts of uncertainty in the experimental measurement. Now let's take a look at this number here. And let's count up the number of significant figures. Well, these zeros, which appear on the leading edge, they do not count. These zeros, which appear on the trailing edge after the decimal point, they do count. So if we count up the total number of significant figures, we'll get 1, 2, 3, 4, 5, 6, 7. So in this case, there are 7 significant figures. And finally, we have one last case which is ambiguous. And this occurs when you write your answer as an integer, like 1,600 kilograms or 4,000 kilograms, no decimal points. In this case, it's not clear how many significant figures there are. For example, when you write 1,600 kilograms, do you really mean that there are 2 significant figures? In which case, that means that your actual answer would be somewhere between 1,550 kilograms and 1,650 kilograms. In other words, somewhere in that range. That would be the cases if there were 2 significant figures here. But maybe you really mean, no, it's 1,600 kilograms, and you really think that there are 4 significant figures here, in which case you'd be claiming that the actual range is somewhere between 1,599.5 kilograms and 1,600.5 kilograms. Again, to recap, if when you write this integer you intend there to be 2 significant figures, that means your possible range of values in the actual experimental measurement were in this range. But if when you write this you really intend that these 2 zeros here are also significant, so there's a total of 4, then you really mean that this answer that you wrote here is in this range, somewhere between these 2 numbers. So it's ambiguous. There isn't a set standard notation in terms of if you see this, how do you determine how many significant figures there are? You actually have to know what was going on in the experiment because the way this is reported is ambiguous. Likewise, for this one, there might be just one significant figure, namely the 4, or there could be two, the 4 and the 0 might be significant, or maybe 3, 4, 0, 0 significant, or maybe all 4 of these are significant. Again, without any further knowledge, we can't really say what the person who wrote this intended. So the way to get around this ambiguity, this ambiguous case, which occurs when you write your answer as an integer with no decimal points, and the trailing digits here, by trailing I mean these, when they're zeros, that's the ambiguous case. And so the question is, well, what do we do to get around that? Well, very simple. The idea is as follows. If when I'm writing, let's take this first example here. If when I'm writing this 1,600 kilograms, I really mean that there are just two significant figures, in other words, that the actual value is in this range, then I can simply write this in scientific notation and write it as 1.6 times 10 to the third kilograms. And that's indicating to the reader that there really are just two significant figures here, 1, 2. On the other hand, if when we write this, we really mean that there's 1, 2, 3, 4 significant figures, then the non-ambiguous way of expressing that would be to write it in scientific notation as 1.600 times 10 to the third kilograms. When we express it in this fashion, it's clear that there are 1, 2, 3, 4 significant figures. So this case, when you just write it like that, is a little bit ambiguous. Next, we'll see how to keep track of significant figures when you're adding or subtracting numbers. Suppose, for example, I measure the mass of a particular object and it comes out to be this. And then I have another object and I measure its mass and it comes out to be this. And I want to find their combined mass. Now notice that the first mass has 1, 2, 3, 4, 5, 6 significant figures, but the second mass only has 2 significant figures. So when we add them together, how do we keep track of the significant figures? Well, it turns out to be fairly straightforward. Here's what you do. We'll take the two numbers, line them up the way you normally would if you're going to add them together, and you add them. Ignore significant figures and simply add the two numbers together. This number plus that number, stick it on your calculator if you like. This is what you'll get. Okay, now we're going to deal with the significant figures. Here's what you do. Go to the first number and find its rightmost significant figure. In this case, it's the 2 here. Then go to the next number that you're adding and find its rightmost significant figure. In this case, it's the 5. So now here's what you do. This is what your calculator gave you when you added them together. So you start scanning along here from left to the right, and as soon as you hit a column that you circled, then that is your last significant figure. So we would report this then. Anything beyond that we ignore. So cross out that 2, and we would report this as 7.3143 kilograms as our final result. Let me illustrate with a related example. Suppose I wanted to add these two numbers together. Notice this first number is a little bit different than what I had originally. So I want to add these two numbers together. Again, they have different numbers of significant figures. This one has 6 significant figures. This one has only 3. So I'd line them up and add them together. Or if you like, stick them on a calculator and add them together and you get this. Now here's how we deal with the significant figures. Once again, we'll go to the first number and find its rightmost significant figure. That's the 7 here. Then we go to the next number and find its rightmost significant figure. That's the 5 here. So then we scan along here and from left to right, and as soon as we hit any column that we had circled here, that's our last significant figure. So this column here where the 3 is, that will represent our last one. But notice that the number next to it is a 7. So we're going to round this up, and we would write this as 7.3144 kilograms. This would be our final answer expressed to the correct number of significant figures. Let's do one last example. This time we're going to add together 3 numbers and keep track of the significant figures. So here again we have our first number. It's got a total of 6 significant figures. The next number has a total of 2, and the last number has a total of 4. So you grab a calculator and you add them all together, and this is what you get. Okay? Now, how do we figure out the total number of significant figures that we should actually keep in this final answer? Because we're not going to keep them all. We'll again do what we did before. So we line up these 3 numbers the way you would if you were adding them together. Make a note of the rightmost significant figure of each number. So in the first number here it's the 2, the next number here it's a 5, and here it's a 2. Okay. Then when we have our final answer here, we scan along from left to right, and we keep on going column by column until we hit a column where we had circled the number. So we had circled this number here, so that means our 3 is the last one that we're going to keep. And I look over here, that's a 432, so we're going to ignore all that. So our final answer we would express as 17.53 kilograms. If you want to do subtraction, it is the same exact procedure. There's no difference between adding and subtracting. The rule for keeping track of significant figures when you're multiplying or dividing 2 numbers is even simpler than when you're adding or subtracting numbers. Let's look at an example here. Suppose I want to multiply 7.32 meters per second by 0.81 meters. Well, if I just go to my calculator and multiply those 2 numbers, this is what it will spit out. 5.9292 meters. But now the question is, how do I properly report this in terms of significant figures? So here's the very easy rule. Look at the first number that you're multiplying or dividing. Count up the number of significant figures. This one has 1, 2, 3 significant figures. Look at the next number. This one only has 1, 2 significant figures. You always choose the number that has the least amount of significant figures. So in our example, it's 2. That means when reporting our final answer, we are only going to keep 2 significant figures. So that means we will keep the 5.9, and then we're going to get rid of the 292 here. So we would report our final answer as 5.9 meters because that has 2 significant figures. Let me illustrate with another example. Suppose we wanted to multiply 4.51 meters per second by 0.6 meters. Well, if you do this on your calculator and just plug it in, this is what you'll get. 2.706 meters. Okay, now let's properly report this in terms of significant figures. We look at our first number and note that it has 3 significant figures. We look at our second number here and note that it only has 1 significant figure. Therefore, we are only going to report our final answer to 1 significant figure. So that looks like we would just normally keep the 2 here, but notice that we have a 7, so we're going to round up and report this then as 3. So I'd write this as 3 meters, because that has just one significant figure. By the way, if instead of just multiplying 2 numbers together, I was, say, multiplying 4 or 5 numbers together, the procedure is very similar. First, you just multiply the numbers together. Grab a calculator and multiply them out, keeping all the decimal places. And then you scan through the numbers that you were multiplying together, find the one that has the least number of significant figures, and then when you look at your final answer, only keep it to that least number of significant figures. The rule for division is the same as the rule for multiplication. When you divide 2 numbers, you look at the first number, see how many significant figures it has, look at the second number, see how many significant figures it has. Whichever one has fewer, that's what you go by, and that's how many significant figures you keep in your final answer. Please now go to the exercises associated with this tutorial and give them a try. You can check your answers with the solutions that are provided.